All right, we're on air. Hello, I'm Dan, the host of JavaScript Enabled. Um, cool. Let's see. So it is Thursday the 12th. Hello, Tiffany. Should we do introductions? I guess we should. Like I know everyone here knows each other, but it's on air, so I guess we should briefly introduce ourselves. So I'm in Oakland, California. I am a Rubyist and a JavaScript developer. I'm looking for work. If you have a job, let me know. That's my story. Tiffany, do you want to just briefly introduce yourself?
Yeah, I'm Tiffany. I'm in Pittsburgh, and I'm a student at the University of Pittsburgh.
Cool.
Computer science.
Yeah, awesome. I love your stuff. I love following you on Twitter. You've always got news. You're always working on something cool and new.
Thanks.
Yeah. And Mark, you're at the lounge. We can't really see you, but do you want to introduce yourself?
Hey, I'm Mark. I'm currently in the Navy. I'm working on JavaScript and doing free code camp and other things like that. And we're just excited to be here this week. And this weather's crazy. I don't know whether to wear a t-shirt or a cardigan. I got a cardigan on today, but it's like
Yeah.
75 degrees.
Okay, San Diego, right? So,
Yep.
it's finally cold up here, like actually cold at night.
Like
Um,
it's like 50s in the morning, so I'm like, nah, forget it. I'm breaking it all out.
yeah.
Well, it's
Um,
going to be 30-some degrees here tonight.
yeah. Okay, you win.
Nope,
Or lose.
that's too cold. That's too cold.
Cool. So, last week we kind of talked about the zombie challenge, and I got to be honest, like I'm looking for work. Like I didn't really do it myself this past week. Um, so I think I'm allowed to like miss one every once in a while. Did either of you see it or like want to talk about it? Let me know. Like either way is cool. Like that's how I'll just like start off the hour.
I
I
didn't
honestly,
see it.
yeah, I didn't even look at it either. I was finishing up a Udemy course. I finished that up, added that certificate to LinkedIn, and then trying to finish up reading design patterns for object-oriented software. Just trying to learn those words like singleton and stuff like that because I always heard them. I'm like, what are they? I was like, I never really knew what design patterns were, so trying to get in that area right now.
Yeah, design patterns are super fun. Oh, hey Mark, did you see Saran posted tonight on Twitter that she's interviewing the Free Code Camp guy?
No, I haven't even checked Twitter today.
Oh, okay, yeah, I think she might be doing it like right now as we speak.
That
Um,
would be really interesting.
dude, if you have any questions, pop over to her Twitter and just like reply. She might see them. Hey Corey, how you doing?
I'm doing okay. How are you?
Good, pretty good. Good to see you again.
Likewise. I've been in two different countries and like a half a dozen different states.
Ooh, traveling man.
Like 6,000 miles,
Oh, awesome. For work or for fun?
just for fun.
Awesome. Cool. Good. Um, Probably getting cold up there in Maine, isn't it?
Actually, no. It's still 50s.
Okay. Well, actually, it's 50s here, and I was saying that's cold. So there you go. Um,
Normally, at this time of year, it's in the 30s.
okay. Yeah, that sounds right. November, New England in November. Um, cool. Okay. So I guess we mostly are. I guess we're done talking about the zombie challenge. Tommy Noe, who might come along later, did work on some of it last week and might have more. So he may like have something to share with us. Um, Does anyone, before we go into like the next week's challenge, I don't want to like rush us along. Does anyone have like a project they're working on or something from like Mark from your Udemy course or Free Code Camp that like you built recently that you want to show off?
No, I didn't really build anything. I was just finishing up a course like teaching the fundamentals of JavaScript, the under the hood JavaScript. So I just wanted to finish that up so I could put your certificate on LinkedIn. I'm starting C++ on the 16th, so that should be interesting.
It's a lot
Cool.
different.
Yeah, I'm kind of nervous actually.
Why did you decide to tackle that?
Oh, it's I have to take it requirement. One of the courses I have to take for the degree.
Oh, okay, cool.
Yeah. Like I would have steered around it, but there's none. It's required. And like,
Well, the second language is always easier than the first, so I
well, I
would.
feel like JavaScript was like kind of my first language, so it's like there's too much freedom. And then now I'm gonna go into, I guess this is considered a legacy language.
Mhm.
So just gotta constrain myself.
C is still really used on anything that performance is critical on, and if you were to do like game design, that's all done in C++.
Oh, okay. All right. But it should teach me some good fundamentals.
You get to learn how to manually allocate memory.
Yeah, that's what I'm kind of nervous about.
I'll be learning that pretty soon with the Java courses that I'm taking.
See, Java wasn't that bad. I feel like we didn't really touch like the memory area. I don't even know if we did. Like the program was really simple, and it was spread over 8 weeks. So I kind of breezed through that.
I'll be taking the school that I'm going to is predominantly Java, so I've got about 60 more credits to go, and I'll be taking the intermediate programming course next semester, so it'll be more involved Java than I'm doing right now.
Cool. So are you sort of in introductory courses right now?
Yeah, I'm in an intro to programming course.
Oh, cool. Okay. I can never tell like which of your stuff is for school and which of your stuff is just because you're like tenacious and want to learn new stuff.
The Java stuff is school stuff.
Okay. Cool. Yeah, my college had. Well, I mean, I didn't do CS, but my college was primarily a Java-based program too, not C. Cool. Hey, Tommy, what's new?
Hey, nothing much.
Good to see you again.
Good to see you guys. I had to finish up a couple things, but I am here now.
Cool. Did nobody else did any work on the zombie challenge? Did you have any more from last week that you wanted to chat about or to show off?
Yeah, sure. Let me pull off something. So the version I have that's just in like that I have on Git. Well, I don't have it all up on GitHub yet, but the version I have up on there, I need to tweak a couple things. But I have a little prototype that I was working on in a code pen, and I can show off some of the code that I have, like in the Sublime. But I can show you what it looks like now in the code pen. It's a little bit better. It's still a little like not super pretty, but it's prettier than it was.
Okay, cool.
So yeah, let me see if I can pull this up real quick. 1 second. I need to adjust this. That's not what I wanted. All right, let me see if I can show my screen here. All right, so can everybody see my screen?
Oh, that looks awesome. Yeah, can you make the text size a little bigger?
Yeah, I don't know if it's gonna jack up the emojis or not, but I will try. Oh, okay, that actually worked pretty well. Okay.
Oh, that looks really good.
So basically I took essentially the same thing that I did last week, and I tweaked it some, and now instead of it being just static text, I turned everything into emojis, because you can actually put emojis in Unicode on a page, so I found a site to do that. So I basically, all the humans are these smiley faces, the zombie is the skull, and then the wall, everything that's a wall or like a pound sign is this, whatever, under construction.
I like that they're monospaced too. I don't know if that was on purpose or if that's just how emojis work, but I like that.
Yeah, no, it ended up working out pretty well. So the way I have this set up is it is being displayed via Canvas. So what it's doing is like, and I can show off the code here in a second, but it's basically taking that array, like the same map that was on the challenge page, and then basically transforming each one of those into emoji form. So instead of an H, it's a smiley face. Instead of a Z, it's a skull. And instead of pound sign, it's the barriers. And what we can do here is if I click start, then everything's going to start moving. And then, when a skull runs into a human, it turns into a skull, or the human turns into a skull. So I need to check the settings on this CodePen because I can't remember, but I have it set up to where actually the humans can escape. You can't. It's kind of hard to tell. Like, you'd have to pull up the console to kind of see it. But basically, what it amounts to is when a human gets within like an adjacent space of a zombie, then we roll a dice. We basically just get a random number. If the random number is 4 or above, then the human can escape, and it tries to go to a space that is not adjacent to a zombie. And if it's lower than 4, then it just stays there, and then the zombie eats it.
Cool.
And then once all the humans are turned into zombies, then everything stops. So then you can reset it, start it again. You can pause it, start it up again. We can hit reset to go back to the beginning. There's still some other things I want to do to it, and I want to get it so the version on GitHub, I gotta fix it. There's some things that went wonky with the demo I was trying to do. Like, it sort of works, but there's like the reset doesn't work very well. So I have to figure that out. But yeah, the main thing that I figured out with this, and I'm trying to get back to the view with the code. The code's kind of hard to see in this view because it's all in one place. I have it split out in my Sublime so I can get to it. But the main thing I sort of learned with this is that I don't know if anybody's familiar or has looked into graph algorithms before. I sort of knew it. Like, have you ever heard of depth first search or breadth first search?
Yeah, I
So that's what I'm basically doing here for the zombie. So it looks, and I can adjust the setting, but it essentially it can sense where the closest human is and try to move towards that path. So it does a search. It basically just keeps going around and around its neighboring spaces until it sees a human, and then it backtracks and makes a path, and then it tells the zombie, okay, start moving on this path, and then it just keeps doing it every turn to see where the closest one is. So I can kind of show that off. See if I can pull up some code here. See if I can switch over to that. I need to make this a lot bigger because this is really small, the code. Want me to show off a little bit of the code here? I'm not going to go through every little detail, but it's a little bit more organized than it was before.
Sure, yeah, maybe that search algorithm would be interesting to look at.
Yeah,
that's
sure.
what I was going to ask too, if I could see the algorithm.
Say it again, sorry.
The same thing as Dan said.
Okay, yeah, cool. So yeah, just to give you a sort of a background on how this is set up, let me get rid of this as the whole thing here, and I'll bump up the demo. So the way this is organized is just at a very high level. So I've got these all separated and required out with Node. So that was the thing, trying to get it to display in a browser, so I'm working on that. But essentially we have different files that account for different types of objects. So we've got actors. This is what determines what's a human, what's a zombie. So I have a couple different actors here. The human, and then this symbol is the Unicode symbol for it. And then I'll get into what the act does, and because it kind of plays in. But each actor has an act function which determines what it's going to do on each turn, like when the world moves. So that's what determines whether a human's going to try to escape or if it's going to try to move to just a normal space. Same thing with the zombie. And then there's also a wall, and that's just the Unicode symbol for the barrier. Let's see. We also have the world. This is kind of a big, where the magic happens. It takes in a seed or basically a two-dimensional array, which shows you, it's a two-dimensional array of strings. So that's what brings out the pound signs and the H's and the Z's. So, like, for example, this would be what you would plug into it right here.
Mm.
and then that gets transferred and transformed into what you see on the screen. And it also gets transformed into the background. Every little piece of these gets turned into one of those actors. So each one of these spaces gets turned into an object, essentially. And then that's how we determine all the logic surrounding it. So let me go to this view function. So this is where we determine all of the different, like how to search through this algorithm here. What this view object does is it essentially connects an actor to the world, and it allows the actor to look at the coordinates around it. So to back up a little bit, let me go back to this. So what I do is each space here, even the blank spaces, gets turned into like a coordinate on an XY coordinate in a plane, right? So it starts up here at 0, 0 and goes all the way down to whatever the length and width of this map is. So we keep track of where everything is by looking at what its coordinate is. So for example, this H, it's in 0, 1, 2, 3. So its X is 3, and then its Y is 1. And then what this view object can do is help that actor to look around the spaces around it to see what's there. So that view can essentially, whoops, I keep jumping around. That view can tell it, okay, look at your surrounding spaces, and eventually it will tell it that, hey, you've got an H right here in whatever coordinate this is, 4, 2. You've got spaces here, you've got a wall up here. So that's what helps determine where this human's going to move. And the humans basically, they're pretty binary. They just look around at their adjacent spaces, at their neighboring spaces, and they find a space. They just pick a random space and move to it.
Mm-hmm.
I do have a little smarter way for the humans to move, which is what it's using right now. It essentially looks around for zombies, like within a certain radius, and if there's a zombie over there, it tries to move away from it. So that's where it kind of attempts to escape from a zombie, but it's kind of hard because sometimes these humans will move before the zombie moves, so it'll accidentally move right into where a zombie's going to end up being anyway. So it's sort of hard to. It would have to be more complicated to get around it.
Just like a zombie plague.
I know, right? It's just like all the movies. Humans are really stupid.
Hey, can I see it in the code?
Yeah.
The check?
Yeah. So here's what the view does. So first, we look at this is adj list or adjacent list. Let me space this out so it's a little bit easier to read. Also, what I should say is up here we keep track of all of the surrounding directions. So essentially, all of these equate to like north, south, east, west, northwest, blah blah blah. So we keep track of all of those cardinal directions. So we can use that down here. So for each direction, like around a certain coordinate, we return whatever its adjacent coordinate is. So let's say, for example, we pass in the coordinate 3, 1, so x3 and y1. What it's going to do is for each one of these directions, it's going to spit out a list of new directions, basically adding whatever's here. So 3, 1, this will end up being 3, 0, and this will be 4, 0, right? So it'll give it the north, south, east, west, northwest, southwest, all the directions surrounding it. So we get a list of all of those surrounding coordinates first. It also does a check to make sure that that coordinate is valid, so that it's actually in the world. If it's not, then we don't want it to look there because that would be a waste of time because there's not going to be anything there anyway.
Mm-hmm.
So that's part of it. So we get this adjacent list. This look at function, all we do is we take a coordinate in and we spit out what this function that returns whatever the character is in that space. So if we pass in a coordinate that has an H in it, which would be human, then this would return an H. So this is what we can figure out in a particular space what it is, whether it's a space or an H or a Z or a wall. That's what helps us determine that. Look for, this is what helps humans figure out what's around it. So essentially what it does is it, for a given coordinate or whatever coordinate you pass this view object, it grabs the list of adjacent spaces around it. So this is what ADJ is, all of the adjacent spaces around a certain coordinate. And what this does is it returns a filtered list of all of the spaces surrounding it that match the character we're trying to find. So, for example, if we go to the actors here, one of the things that the humans try to do is move, right? So what we can do, and what I used to do on this is we would say, okay, look for a space. So it's going to take in whatever coordinate we pass it, look for all the adjacent spaces around it, basically anything that doesn't have a character in it, and then it's going to return that list. And then in this next function, find, we take that list and return a random coordinate that we have in that list. And then that's how we determine where we're going to move. So that list is this list gives us back all of the available spaces that we can move to if we're looking for a space. Or like for a zombie, it's going to return all of the available humans around us. If we pass in an H, we can make it look for anything. But it's going to give us that list. And then this find is just going to give us a random coordinate from that list. And then we can use that find to then make it our target for what the actor is trying to move to or what the zombie's trying to eat, et cetera, et cetera. So that's the basic algorithm. The more advanced one, staying away from it. Essentially what this does is this function, we pass it a target. We say we want to stay away from some character. So if we put in stay away from Z, we want to make sure that we're moving away from all of the zombies on the map. So what this does is first it's going to look for all the spaces around a certain coordinate, and then it's going to filter it down and return all of the coordinates that do not that are not adjacent to whatever our zombie is. So I'm trying to think of a good way to show this off. So for example, if we go back here and let's say we move the H closer to the zombie, right? So what this is going to do is it's going to look at all the spaces around us. We've got a space right here, space right here, a space below it to the south, etc. So once it finds all those spaces, it's going to check those spaces' neighbors as well to see if it's next to a zombie. So for example, this space right here is next to a zombie. So we don't want to move to this space because we'd be moving right next to a zombie. Mm-hmm. So we eliminate that space from the list. And then we just pick a random space from the other available spaces that we have that aren't next to zombies, and then it picks one to move there. So it's not super complicated. It's just we look at its neighbors and then we look at its neighbors' neighbors and make sure that they're not next to something we're trying to get away from. Does that make sense?
Yep, sure does. Sure does.
Now the zombie, the way the zombies try to find the humans is a little bit more complicated. So there's this function called find BFS. So this is, I just have it standing for find breadth first search. And all these names I'm going to go back and try to organize out a little bit more, but this is just what I had for the time being for this prototype. So if you're familiar with breadth first search, essentially what it does is you're given a spot on a graph or a spot in a grid. And what you do is you look at all of that spot on the graph's neighbors, all its connecting spots. And then once you're done looking at all those, then you look at its neighbors' spots as well. And then you just keep going and going until you either get through the entire graph, or if you're looking for a specific thing in the graph, you can tell it to stop when it reaches that point. So in here, we're passing it in you can pass it a target. So this is what we'd be looking for, and then also a radius. So this is how many times and how many levels of neighbors do we want to go to before we stop. And we make a couple different variables here. So one is a queue. This is how we determine what we still need to look at. So the neighbors that we have not looked at yet came from. This is an object which we keep track of to see what coordinates we've already been to, or what coordinates are connecting the other coordinate, like how we got to this point. And I can send you guys a link of how I learned all this. It's explained a lot better. It's really easy to read, and it has a good diagram on it. So I'll send that after this. But this is essentially where I got it from. And then we keep track of a couple other things here. Essentially, what we do is we go through. First, we take the coordinate that we're on right now, and we push it onto the queue. And then we set the first came from. We set it to null because we didn't come from any coordinate we started here. So essentially, the next place we look at, it's going to come from this coordinate and then all the way down. And then while we have items in the queue, we're going to essentially go through the queue and look at all the neighbors. So first we do shift to essentially take the first item off of the queue, and that becomes the current spot that we're looking at. And then if we're looking at levels, we also have a way to, I'm not going to go into this, but this is how to determine how deep down the graph we're going, like how many neighbors we're going to look at, levels of neighbors. And then if we're above that level, then we're just going to return false if we haven't found anything yet. Otherwise, we're going to look at what the current item is at the space we're looking at. If it's equal to what we're looking for, then we're going to break out of this graph and then go down, and this essentially returns the path of how we got to this. So it's essentially pathfinding. It's going to look through all of the nodes we've looked at and figure out what the shortest path to the target is that we've came from. Otherwise, if we don't find the target at this current spot, then we're going to go through all of this current spot's adjacent neighbors. And for each one of those, we're going to look through. First, we're going to check to see if we've already looked at it. And we're going to make sure that whatever we're looking at is either a space, so that it's an available space that we're looking at, or the target that we're looking for. And then for each one of those, we're going to push all of its neighbors onto the queue, all of its valid neighbors onto the queue, and then say that we've already looked at it. And then it's just going to keep looping back through this queue and look at all the neighbors. And then eventually it's either going to find the target we're looking for, or it's not, and it's just going to break out of it. Let me go to a good way to explain this and a good way to show this. Let me pull something up here. And I'll put it up on the screen in just a second. This is the site that I got this from. Let me screen share. I mean, I adjusted it a little bit for my purposes, but okay. So can you see my screen here with the site?
Yeah.
So this site's called redblobgames.com, and it's got some interesting tutorials on. It has mostly to do with games, so algorithms for games. It also talks about graphs, and that's how I sort of used graphs to make the grid. But essentially, this is called Introduction to A*. A* is another, or A', however you want to say it. It's another algorithm to look through a map and find the shortest path to get to something. It's more complicated than what breadth first search is, and it requires a different type of graph. But here's an animation that's going to show what breadth first search does. So if we start this, as you can see, it's building out. Every one of these spaces that gets colored is a space that we visited. So that's essentially what my algorithm is doing. So we start off at this main point, and then we look at all the neighbors. And then we branch off and look at the next neighbor's neighbors and keep going. right? And eventually we get this big radius of spaces that we've looked at, right? And then we just keep going. In this case, we're not looking at a particular target. It's just going through the entire graph. And this goes into deeper about how to do it. It also gives it some pseudocode in Python. Actually, this isn't pseudocode. You could actually put this in, and it would work in Python. Cool. But for example, here's the path finding. So for each one of these spaces, we can circle back and see how to get there based on this code right here. So we can say, okay, what's the closest way to get to this space? Well, we can see that, okay, we have to go up diagonally, and eventually we hit it. So it kind of works backwards. You branch out to the neighbors until you get to your target, and then you start from that target and go backwards until you get to where you started, and then that's how you figure out your path.
Sure.
And then this is the early exit. So this is what I'm doing. So if you're not looking for a particular target, you'll just go through the entire graph. You'll eventually hit a target if you're not stopping early, but you're going to look at every single space. If you're doing early exit, then you keep looking at all the spaces until you hit your target, and then you break out of the loop. So that's what I'm doing. So that way I'm not looking at the entire graph. I'm just looking, like for example, for the zombie, if I'm looking for the closest H, then I'm just going to keep going through this graph until I hit an H, whatever the closest H is to me, and then I'm going to stop. Then I'm going to make the path from that H back to my zombie, and that's going to be how I figure out where to move next. So essentially, the zombies are really greedy. They're just looking for whatever the closest H is, closest human, and then they're going to start trying to walk that direction. But yeah, then it goes into deeper stuff, so there's all sorts of crazy algorithms that you can do for other types of graphs. But I essentially took inspiration from this site and tried to make it fit the challenge, and it was pretty cool. I just started working on a lot of this today, so it's still kind of not super organized, but it ended up working out pretty well. If you bump up the like if you take out the radius of what it's looking for and you just tell the zombie go look at the entire graph and find the closest human, it's going to start walking that way, and as soon as it hits the first human and you get more zombies, all the humans are gone within like 2 turns.
An efficient human slaughtering algorithm. Fantastic.
So yeah.
How did you stumble across this? Like, what was your initial search?
Say that again?
What was your initial search? How did you stumble across this algorithm?
So I had, I had learned about this a little bit before, and I was just searching. Like I thought that there's got to be an easy way to use this grid and turn it into something and make it search easier than what I was trying to do initially. And then I eventually, just through Google searches, I honestly can't remember what I was exactly searching for, but I stumbled upon this Red Blobs game site, and what I did was I started, where is it? This Intro to Graph Theory here. So when I saw this, so right, you've got a bunch of spaces here. It's exactly like it looks, in the zombie challenge. And when you look down and you see the graph, this is where it sort of hit me. Oh, all of the little spaces and all these coordinates are connected to each other. So using the graph algorithms on here, we can more easily find how to move to a different space, how to find something that's across the grid, instead of looping through every single space on the grid to eventually find it. So it's just a more efficient way of looking through the graph and getting to something quickly. And then this goes into, what a graph is, how it's set up, and this is really where I started. So this is where I got the directions, but I also added in diagonal directions. So all this is north, south, east, west, but I also added in northwest, blah, blah, so things can move diagonally. Cool. But this really gives you a good sense of how to set up this challenge and put it sort of in the terms of a graph. So I actually learned a lot about this, not just JavaScript-wise, but algorithm-wise, data structures too.
That's awesome. Yeah, that stuff is so powerful to learn, even if you never get job interviewed for it or anything. It's always like such great problem-solving tool.
Yeah, well, and it was good too because it like I had learned about it before. I think I actually learned about it initially through the Odin project, which Dan, I'm sure you're familiar with Viking Code School, because there's a spot part where you go through graph algorithms, and I looked at it and I said, well, this is cool, but I don't know what I would use it for. And then having this challenge and seeing a tangible way to use like one of the algorithms that you always hear about was really nice. It finally gave me a sense of, oh, okay, this is what I could use it for. And then this site also talks about different use cases for graphs that I didn't even think about. So this site is really, really cool. It's got some other tutorials that I haven't looked into yet, but if you're interested in games and game algorithms, this is a really cool site to look at.
Awesome. Yeah, I will. Can you share that on the Slack channel, like now or when we close for the evening?
Yeah, absolutely.
Awesome. Cool. Yeah, this looks great. I can tell you put a lot more work into it since last week.
Yeah, I really wanted to make it look like something different than just the text, so that's why I really wanted to make sure I had the like the emojis up there or something. Initially, I was looking for like game sprites to try and put in there, but that was just going to be too complicated. And then I stumbled upon, I could put emojis in here. Oh, that's fine. I'll just use that. And it ended up working pretty well.
Very cool. Yeah, and also if you don't mind sharing that to the discourse thread, like if you've got a GitHub or the code pen, I'm sure some other folks would love to see it. Like I know other people, at least one other person in a different language group posted a solution. So
Yeah. Real quick, could you show the controller? How'd you tie everything together?
Yeah, let me pull that back up. Let's see. So I don't really have a control, I don't really have it set up like in MVC sort of fashion necessarily. But basically everything comes back to the world. The world object is really where everything sort of feeds into. One thing I didn't show was the actual graph. So I have another object called a graph, and this is sort of how the graph is set up in the background. It essentially just creates a giant array with the size, which is just the total size is the area of the array that you send it, so whatever the width of the array is and however many lines in the array there are. And then you can set the coordinates, get whatever's in there, and then check if it's valid. But the world is where everything ties into. So this is where everything besides like the actors are separate. But if we look at, let me see if I can go back to my demo code. So this is what I have essentially on the code pen right now. So we start off and we create a world. We give it a map, which is this array. And then this object here is the legend. But what this does is we essentially tell the world what each character is, what it equals. So with this, we tell it that a wall, this pound sign corresponds to this wall object. An H corresponds to a human, a Z corresponds to a zombie. So this way, you can change all these up, or you can add different characters in here and make it different. So it dynamically sets whatever this character is to the actors in the world as it goes through. So that way you can kind of just mix and match, add new things to it, take things out if you need to. Let me see. This goes into something else. The turn. This is where everything sort of happens here. So essentially, what this giant for loop is doing. This is just my stupid, clever way of getting around doing a nested loop. I managed to go through the entire grid array in one pass by essentially. God, I can't even explain this right now. I can explain it later, but trust me, and if you want to try this out, it goes through and makes this goes through essentially takes a nested loop and makes it one. But basically, we go through each coordinate, we get what's in there, we check to see what it is. If it's an actor, which means if it's one of the characters, and it has an act function, and it hasn't already acted, then we go to this resolve function. This is where it essentially says whether it moves or it bites based on whatever the actor's actions are. So the actors will say, I want to request a move. Or if I'm a zombie, I want to bite something. And then it checks here and makes sure that everything's good, and it will, like for moving, it takes whatever coordinate it was at before and sets it to null, which is a space. That's sort of instead of an object for spaces, I just have null. And then we essentially just swap it with wherever it's trying to go. So we move the actor to whatever its target is in the action. There's a lot to it, and it would take I could go over this forever, but I'll post this code up on the GitHub and try to organize it out a little bit better so it makes more sense. But yeah, there's not necessarily a controller, or it's basically just a bunch of objects, different files with objects in them, and then I essentially have a demo file which goes through, makes the canvas, draws everything out. That was a whole nother thing too, is drawing a canvas and making everything show up to the screen canvas-wise. That was pretty cool, but that's also really confusing, and I'm still trying to learn that a little bit better.
Cool. Yeah, Tiffany posted in the chat where she could find it on CodePenning and GitHub. So yeah, if you post those links, that'd be awesome, because I'm sure.
Yeah, I will. The GitHub is still a work in progress, but I will definitely post the CodePen here, because that's pretty much ready to go. I will post that now, actually.
Cool. Okay, so yeah, does anyone have any more questions for Tommy? If not, I'll post the next challenge and we can talk about that.
And sorry if I didn't explain that super great. I'm still trying. That's another thing I'm working on, is trying to explain what I'm doing a little bit better. Because a lot of times I just put it down there and it works, and then when I try to go back and look at it, I'm like, how did I do that? So, but yeah, if anybody has any questions, feel free to ping me, and when we can set up something, I can walk through what I did a little bit better.
No, that was good right now. Looks like a lot of work was put into it. A lot of head banging.
Oh, God, I seriously redid this like 8 times. There's a backup folder that's on my GitHub right now, and there's like Zombie 1, Zombie 2, Zombie 3, Zombie 4, and it's just me starting off doing it a certain way and then thinking, well, I could do this easier, I think. So then I scrap it and go to the next one. Oh, I can do this easier. So it took me about 8 iterations to get to where it is now. That's not counting all the canvas stuff either. That's just the getting it to display to like the console. So yeah, this one was definitely a challenge for me, at least.
Cool. Well, so I'm going to post a link to the next challenge, which is a like code breaking kind of challenge. This one's I think there was some concern that like the zombie challenge or the Anti-Up challenge were like maybe too intense for some people, so they wanted something like that you could ease into at different levels. So this has a few different levels. Basically, it's the first one is to just decode this one encoded secret message, and then if you're able to decode it, then write the program that can encode it, moving the other way, and then adding like capital or lowercase recognition into your program there. So does anyone have any questions about it, or like just initial thoughts, having looked at it now?
Well, I know this is one where a lot of like I guess I don't know if intro to programming books or a lot of programming books have this as a as somewhat of an example in a certain way. So there's a lot of information on how to do this that I can remember. I haven't looked into it super deeply yet, but I know it's something that is pretty common.
Oh, cool. Oh, Mark asked how long are the challenges. So Jamal Hansen is coming up with new ones every 2 weeks. So for us, that means like basically this week we'll close one challenge and then sort of open the next one, and then next week we'll just talk about the new code breaking challenge, and then the week after that we'll close the code breaking challenge and start a new one. So 2 weeks more or less, but like 3 meetings to talk about it, and this is the first meeting. Does that make sense?
Yeah, that makes sense.
Okay, cool. And yeah, if anyone wants to work on an old challenge and bring that in to talk about it because you just thought it was interesting, like that's totally cool with me. No, just because it's like over doesn't mean you can't work on it or we can't talk about it. Cool. So I know in Ruby there are ways to translate characters into number values. I bet JavaScript has the same thing, although I don't know what it is off the top of my head. So that's my plan for ROT13.
Yeah, just another thing I was thinking about. This is sort of stemming off of that poker challenge, where I had a giant lookup table that mapped something to something else. If you were just going to do 13, you could I guess you could technically just say, A equals this number, B, and just go all the way down, and then you wouldn't necessarily have to loop through it. You would just say, go get it.
Yeah.
I feel like that's kind of
7,000 lines, 7,000 line object for that either.
Yeah. That'd be the brute force approach if you wanted to go that
yeah.
way.
Yeah, cool. So that's one way to do it. That might be like a good just like way to start. Cool. Does anyone have questions or thoughts? I see we have another Corey that joined us sort of while Tommy was sharing. Welcome, second Corey. Corey Ramsey. Good to have you with us. Stay quiet, I guess. Cool. All right. So we got the new challenge out there. We talked about the zombies for a little while. I guess I'll just talk about what else I'm working on. I just started Upcase, which is a Thoughtbot program. It's like $30 a month, but I can tell it's like totally worth the money already. They're not paying me to say that. And like I've been doing their Vim track for the past couple of days. So that's been my like learning focus in between like applying for jobs and like still looking for work. So I know they have a JavaScript track, although it's primarily like for Rails developers. So I don't know how like useful everyone else would find it. But if you want to learn Vim, Upcase is where it's at.
Do you like Vim? I've never used it.
I do. I've used it. I'm not a power user yet, which is why I wanted like people to teach me how to really do it. But I've been using it for probably 6 months now, almost exclusively, and I do like it. Yes, :Q exclamation point is fantastic. That's what you type when you want to quit a document without saving any of your changes. So mostly the things you need to, if your terminal accidentally dumps you into Vim somehow, like say you have a git merge conflict, just know :Q exclamation point gets you away from Vim as quickly as possible. :WQ saves whatever you've changed and exits.
That's happened to me before, and I had no idea what was going on. It took me.
Yeah, you have to like stop and go Google, like, how do I get out of Vim? It's very scary.
I know. I was so confused. That's all I know about Vim is Q and WQ. I don't know anything else about it. So.
Well, it's a lot more than that, and once you like get in the headspace of Vim, it makes a lot of sense. Basically, the thinking is you spend most of your time in a document moving around the document and not actually editing. So when you're in normal mode in Vim, which is how you start, the keys you type are like commands to move move around the document and select things, and you can edit things, and then like to actually like enter text, which is what most people would use a text editor for, or like assume that like that's what the keyboard is for in a text editor. You have to actually enter a special mode that you're supposed to stay in for a very short period of time and then leave. So it's really like makes your eyes bleed at first, but then once you sort of understand what's going on, it's pretty cool. And I see the potential for like power usage and like getting really quick, and like there are all these tricks, and like I've already picked up some cool new stuff that like there's one, the % command swaps you back and forth between matching enclosures. So like if you have an open curly brace and a closing curly brace, you can switch between them. And all of the JavaScript editing I've been doing for the past months, and I didn't know that was there, would have been the most useful thing in the world for like editing all my objects and functions. Corey says, can change things pretty fast, but for coding would still use an IDE. Autocomplete is love, heart. What IDE do you use, Corey?
At work, we standardized on WebStorm.
Okay, I don't know that one. Okay, so is it the sort of thing where like everyone at the office shares key bindings and
Yeah,
pretty
much.
Okay, cool.
Like, we also use like JSDoc, and it is really nice to be able to type like /** and like get the whole frame of that, so you just have to like enter what you need versus like write out each line. But yeah, autocomplete functions, it highlights when you have variables that you don't use.
Oh, cool. Okay.
So like you put a variable in the code, but you're not actually referencing it anywhere else. So it highlights that stuff, and I mean, it's good for that kind of thing. But if you just need to change something really quick and you know what you need to change, using VI or Vim is by far the fastest way to do it.
I feel like there are ways to do that in Vim also with plugins. I don't know what they are yet.
Yeah, but I mean, then you have to go into learning Vim and installing all of the plugins versus having the stuff out of the box.
Yeah, fair enough. Okay. Cool.
Hey,
Mark said, I tried to add tmux to Vim, got stuck trying to close an existing session. All you got out of it is mapping caps lock to escape. I haven't done that yet. I've got some other escape mappings. Does anyone else? Yeah, Tommy, you were going to say something.
Yeah, I was just going to ask, so I've heard of WebStorm, but I've never used it, but I've seen it in context of JavaScript development primarily. Is that what it's used for primarily? Or I mean obviously I'm imagining you can use it for other things, but is it better for JavaScript than other things that you've used?
WebStorm is mostly HTML, CSS, and JavaScript. They have other IDEs like PHP Storm. Or if you really want to go all out and spend a couple $100, you can get IntelliJ IDEA, and that has like references to C and like everything else. That's like their enterprise. This will cover every language pretty much that you would code in an enterprise environment. But for WebStorm, it's fairly inexpensive. It's like $50, and that includes upgrades and things like that. And we use it at work. It is a Java application, and that's probably the worst thing that I can say about it. All the code hinting, and I mean it will tell you if what you wrote could be written a cleaner way.
Oh, that's cool.
So that's kind of cool. Like I said, it does unused variable detection. It's easier to like refactor if you can highlight a variable and be like, I want to rename this, and it goes through the entire file or the entire project, and will rename that variable everywhere it's used.
That's pretty sweet. Okay. I have to see if I don't know if I'm going to spend $50 on it necessarily, but I'll see maybe if there's a free version, like even a trial version.
Yeah, they do 30-day demos, I think, and then past that you can use it, but you can only have it open for like 30 minutes at a time.
So you just keep closing it out and opening it back up or something?
Yeah, and I mean, really, if you're going to be using it that often, you might as well just pay them the money.
Yeah, that's true. No, that sounds awesome, though.
Cool. Yeah. Anyone else want to let's start? Should we restart the browser wars or the text editor wars?
Yeah, I
just
just
like
want to know why would you use an IDE over a text editor? Is it more memory or something?
In addition to the things that I've said, you can also use it for things like debugging call stacks and stuff that you might be able to do in like a browser, but you can do it all in the same environment. I mean, you can use Notepad++ to do a lot of the stuff that I've described, I'm not going to lie. But where the company paid for it, and that's what we're saying, I mean, that's what I use, because that's what I'm told to use.
Right. You learn to love anything if the company pays you to it. Um, cool. Okay. Well, I'm gonna stick with Vim for the time being because I quite like it. It's good. It's good for everything. It can learn JavaScript or Ruby. There are all sorts of like Rails plugins for it that I'm excited to learn. That was one thing that I haven't done is like install that many plugins because I'm worried if I'll install stuff and then only learn like one command for the whole plugin, um, and then it'll be a waste of space basically. So that's what I've been working on. Anyone else have like stuff that they're working on that they want to share?
Yeah, that's what happened to me when I was starting out with Vim. I accidentally downloaded this bundle pack that had 90 plugins, and I did not know how to even find the .vimrc file to delete it. I was like, all right, it's
Oh
done.
yeah, I remember that. You were like,
Yeah,
how do I
I was
do?
struggling. And like, come to find out, it was named differently on Mac. I was like, oh, okay, thank you.
That's too bad.
I don't have necessarily anything that I've been working on. I mean, besides the zombie challenge, which sucked up a lot of my time just because I kept going down the rabbit hole. But here's the I just linked to the site I was talking about earlier at Red Blob Games,
Yeah, cool.
and so I'm a big CodePen fan. And right now on CodePen, a lot of people are doing this. It's called CodeVember. I'm not really sure how it started, but it's essentially a bunch of people are just putting out just a ton of really cool, crazy demos with JavaScript and Canvas and stuff. And I've been looking at it, and I've been after going through a little bit of Canvas, I want to try and go through and do something similar. I mean, the stuff is like borderline art, though. I mean, legitimately, the way they go through and do it. But just go to codepen.io if you want to see some really insane JavaScript and Canvas stuff,
Cool.
and just some other. I just like it because there's just a ton of stuff on there, and not just Canvas related. There's website, web design. There's blogs on there. There's a lot of really cool stuff on there. Other than that, I'll be starting on the new challenge here pretty soon.
Cool. Good to hear. Tiffany, you've been quiet. What are you working on lately, or planning to work on this week?
What doesn't she work on? She got the
What doesn't she work on
podcast,
exactly?
the Medium now on her blog, personal blog. Yeah.
I'm back at Free Code Camp, so I'm at Free Code Camp Treehouse. I'm taking the Udemy course, JavaScript, the weird parts. So I'm trying to get a little bit of more of a handle on JavaScript while I'm going to school. So I want to continue to build this address book app that I'm working on. I'm trying to learn a little bit more about APIs because I want to use Google's Contact API. Even though they don't have an API for JavaScript, there was this neat little gist on GitHub to see how you could use Google Contacts API with JavaScript. So I want to do that. But it's almost the end of the semester, so I've got one more project to do for school. So yeah.
Oh, cool. Okay, so you're coming up on sort of like final projects, final exams.
Yeah.
Okay. Yeah, it probably doesn't leave like a ton of time for for your personal projects. That's
No.
cool though. It's good to hear.
Yeah.
Um, awesome. Corey, are you working on anything like not work related?
I'm playing the StarCraft 2 campaign.
Okay. I don't play StarCraft, but I hope it's fun. Literally everyone on my Twitter feed is talking about Fallout 4. I've never played Fallout. Does anyone know what it is? Can you explain Fallout to me?
Fallout's pretty cool. I don't have Fallout 4, but it's just post-apocalyptic, um, like sort of 1950s, 60s era nuclear sort of Armageddon, and you uh, sort of are the whatever, hero of the wasteland. And it's just very open-ended. You can pretty much do anything you want. You can talk to anything. You can kill anything. I think in this new version you can set up your own bases, and it's crazy looking. I had Fallout 3, and I played it a little bit, and it was pretty fun, but this one is just looks like it takes it to a whole new level. So if you have a next-generation console or a crazy PC that can run it, recommend it. I don't have any one of those, but it just looks really cool.
Cool. All right. Later, Mark. Good to see you tonight.
All right, thanks for the talk.
Bye. Okay, cool. So now I know it's like Nuclear Armageddon sci-fi game.
Yeah, it's
Cool. Yeah, I don't have any time for video games right now, unfortunately. Doesn't stop me from playing Civ 5 every once in a while, but for the most part, no time for video games. Cool. Anything anyone else wants to chat about? We're already after the hour, so I'll hang out as long as anybody wants. But
Yeah, just one real quick shout out. There's a new, I know we're not doing React anymore, but there's a new React course that got released called React for Beginners. It's not free, but it's discounted about 50% right now, and it's really good. And it's run by this guy. I don't know if anybody's heard of. I think Wes. It's either Wes Boss or Wes Bose. He's a really big name in the sort of web design community, and he's got other courses too that are really good from what I've seen. So in case you want to get deeper into React or you want to just buy it now and store it away for later, I highly recommend.
Cool. Yeah, Wes Bose is the one who had that meme that went around that was like JavaScript for millennials.
Oh yeah.
And I remember retweeting that and being like, "Can someone explain this to me?" And then Wes liked my retweet but didn't explain it to me, so I still don't understand like why millennials like React. But in any case, he's now teaching about React, so I guess he like identified that market.
Yeah, no, I think he runs like some Canadian coding school, kind of similar to, Viking Code School or Dev Boot Camp.
Oh, interesting. Okay.
I've heard him on another podcast before, and I mean he seems really really cool, and he knows his stuff. Also, if you like Sublime Text, he has a book about being really awesome at Sublime Text that I'd like to look at some point, because I use Sublime Text, but I'm nowhere near a power user at all. So he's got a whole bunch of stuff. If you look him up, he's got some cool stuff out there.
Oh, cool. Okay. Even though he's a jerk for not explaining his jokes to me.
Yeah,
I'm sure he's a nice guy. I shouldn't say
that. The teacher that explains nothing.
Yeah. Cool. Yeah, anything else anyone wants to chat about? Bye, Corey. Okay. All right. I guess that's it for tonight. It's good to see everybody again, even though people sort of dropped off a little bit. We'll be here again next week, and then the week after that is Thanksgiving, so I'm skipping Thanksgiving, but I'll be here next week.
Okay.
Cool.
Sounds
All right.
good.
Take care. See
Take
everybody.
care.
All right. Bye, everybody.
Bye.